Welcome to the podcasting stage, Eric.
Thank you.
So for people who haven't checked out the show notes or are not at the conference listening to this, who are you? What do you do?
So I'm a software engineer. I also love teaching, and currently I'm teaching a lot of functional programming.
Yeah.
I have a book on functional programming called Grokking Simplicity, and I'm working on another book about domain modeling.
Yeah. That new book is more or less the subject of the presentations you had here, right?
Yes. Yesterday I gave a talk that I think showed to me that I'm really on to something.
Yeah.
That when I put the talk together, it felt really good, and then I presented it, and it was still good.
Yeah,
and people seem to like it. So,
I agree. By pure luck, I managed to catch both presentations, and I'm not sure from where, but I have distinct memory when I started working and read a book, probably some classic, where they had some kind of modeling example where they did the coffee shop type stuff, but object-oriented or something.
Oh, okay.
And it came back, and the reaction was, this version you do is so much clearer.
Well, okay, great. I'll take the compliment. Thank you.
Yeah. So I really think it's onto something as well.
Yeah.
Well, the whole part of it, I feel like emphasizing a bit more that it's worth thinking about these things before diving into the details. I feel like that's something that's easy to lose sight of.
The details.
Yeah. I mean, thinking about the domain and the modeling.
Oh, sure. Yeah. I mean, we're under a lot of pressure. I think certainly that makes it harder because, you just get this JIRA ticket and you're told it's like code right now, like this is due by the end of the sprint.
Yeah.
And so you don't get a lot of time to think about it. I also think that there's a kind of anti-design trend that happened when we switched over to agile.
Yeah.
That there was, because if you in the waterfall world, you would design up front, and then that design would get handed over to the next team, and they would implement it, let's say a simplified model. And so there's this idea of thinking about your code and designing it is bad. It's like an upfront design model, but like you still should design, and you're going to be doing a bad design if you don't think about it.
Yeah.
You're just going to be throwing stuff at the wall and seeing what sticks. And there's a lot of stuff you can do. I mean, one of the takes I try to have in my book is that there's a lot of stuff you can do on the way to code, like on the way to working code, that is design activity.
Yeah.
Like you're making better design decisions, and you're also making progress toward a working system. Yeah,
that's the thing.
It's not like just drawing pictures and thinking a lot. Like you're moving closer.
Yeah, and I feel like that came across really well as well, because it would be pretty easy to make a discussion like that feel very abstract.
Yeah,
and it's like, let me get to the the implementation.
Yeah.
Well, so really that's the right level.
That's the thing. Is like you have stuff like, I mean, I don't want to step on anybody's favorite frameworks or anything. But one of the things I don't like about UML is that it is just drawing pictures. Yeah. And that's very useful because it's easy to communicate with people and it makes you think through it, right? That's good. But then now you have to start over with code. Yeah. And there's another translation step. Yeah. And something can be lost in that translation step. And then there's no step to go back to the pictures. There's no way to do it. So
you won't even know if you deviated.
Exactly.
Unless you map it back.
Exactly. You have to carefully look at the picture and look at the code, and that's not always easy.
Yeah.
So I like the idea of designing in code. Yeah. That code can be a medium for design.
Yeah. So is that how you tend to go about it yourself, like designing it in code?
Yes. Yeah. Yes. And I know a lot of people who do it, and so I'm talking with them to figure out what are the practices that we actually do, because coding you often just do it alone and you don't know how other people are doing it. So I want to get more input on more practices for doing it. But I use Clojure, which is a a language with a REPL.
Yeah.
And we're often running code, trying stuff out all the time. And so coding and designing are happening in this really tight feedback loop. And there's just a lot of stuff to learn from that for even in other languages that don't use the REPL so much.
Yeah, I had a guest on the podcast. It was surprisingly long ago now, I guess, because it always is. But who was describing to me, talking through like REPL-based design, and I really could. I mean, I couldn't quite grasp it myself because I haven't actually done it, but I could see that there's so much here, and there's a like more malleable way to experiment with the code or evolve the code.
It's very different. And I'm always surprised when I step out of the Clojure world and run in a different language. I'm like, but how do you do this? And like, I just want to change this and see what happens. Oh, you have to go through a whole compile cycle just to figure that out. We're lucky that we have this really fast feedback loop. Really easy way to experiment and try something and throw it out. It doesn't work. Try another way. To do like write our program halfway and see what happens. Like, is this halfway good?
Yeah. So that's a lot of experimentation in code.
That's right. That's right.
I think I mentioned that in the email. There's some kind of semi-question in my head about reasoning on different levels about programs, and this level that you're reasoning on here and in other concepts. I've listened to a few of podcast episodes. It's sort of a higher level than I'm usually. I feel like I'm not thinking on the same level usually. And I wonder, like, what the connections are between the levels, or something like that. Like how do you move between the levels?
I don't know. I'm just talking on the podcast,
exactly.
So I don't know.
That's what they're good for,
right? Exactly.
And then stuff drop out of it.
Yeah.
No, but I mean, just to try and get a bit more concrete, like coming up with the concept of lenses, for example. Like how do?
Okay, so that's a story. So I gave a talk back in January. Just at a meetup, and they invited me to speak about domain modeling because I had been working on it and on the book. And when I gave the talk, I really tried hard to make it not come across as a process. Like I'm not saying like do this step, then do that step, then do that step. But it kind of always came out that way when I would present it. So I got all these questions about like, how do I convince my boss to do step one before step? And I'm like, no, that's not the point. Like, it's not a step-by-step process.
No.
And so I was reading this book called Drawing on the Right Side of the Brain.
Oh, I've heard people mention it.
I'd like to get better at drawing. And this is apparently the book. It came out a long time ago, 30 plus years ago. But it's the book about how to draw. And the trick is that drawing is not about, moving your hand. That's not the hard part. The hard part is seeing. That your brain is interpreting what you see so much into like you see what you're seeing is lines and colors and shapes, but you see a rectangle, even though it's at an angle. You still think that's a circle, but the circle is like really foreshortened because. And so the trick is to look at the shape that you actually see, like getting the raw data from your eyes. And in the introduction, she talks about, I think it's 5 different techniques for helping you do that. So one is instead of drawing the shape, you draw the background, and it's the shape as a whole. So it just turns your brain to focus on the opposite. And that helps you see that, it's not a rectangle. It's like this trapezoid. And so she gave a bunch of them. I can't remember them all. But it made me think, that's what I wanted to do. I want to give people these tricks for seeing their domain in a different way. I want to give them a handful of, like, instead of looking at this, look at the opposite, or look at the background, and then that'll give you a better perspective because you're just not used to looking at it that way. And then, of course, the drawing book the nice thing about it was that she was like, and that's a complete list. Like when you think about, and she gave a reasoning why it's a complete list, and it made sense.
Yeah.
But I don't think I have a complete list.
No.
I tried to figure out, like, is there some way? But no, I couldn't figure it out. And the list just kept growing.
Yeah.
It's mostly stuff like, well, this is an important topic, and this is an important topic. And so if I could just make each one into like a set of questions and like concepts that are all very related, that, you know, if you just focus on your domain this way, you can extract this information. And it might not be complete, so you need to look at it from another angle, from this other lens, and then that kind of completes the picture. And eventually, you're getting enough information that you can constrain the problem. Because that's the real big problem with software design. There's so many choices.
Yeah.
So you want to constrain that. You want to know, oh, well, if I look at it from this angle, it's obvious that I don't have to, that it won't be this. And you can cut this problem space in half.
Yeah.
And it's just so multidimensional.
Yeah.
And you just want to look at it from all these angles, constrain until you have some easy choices to make.
Yeah.
Yeah.
And you were currently at, was it like 10 different lenses?
I've got 10 lenses right now.
Yeah, and you talked about 3 of them. And
it can change.
Yeah, of course.
I might throw some out.
Yeah.
Yeah.
But I mean, it's a really good word to put on it, I think. A good label, because it really feels like, you're getting a different perspective or a different focus. But it's not, it doesn't sound like a rule or a limitation or something. It's
I don't want rules.
No, exactly. It's just a different way of seeing it.
That's right.
Alters your vision a little bit, let you see some other details, and then you switch to the other ones.
Yeah, I'm trying to be very cautious not to give rules and recommendations. I've read a lot of software design books trying to, just for my own, improve my own programming, but especially since I've started writing a book on it, I've wanted to like see what other people say. And I'm just very disappointed that it's just all these rules that are mostly more exceptions than actual regular cases. And it's hard. And I know it's a hard topic. So they're doing their best, and like it's really hard to talk about something you're good at. These people are really good at it. You can tell the authors of the books.
Of course.
They're good at it, and they have a rule that they're articulating something, but it's not quite enough.
No.
And what I want to do is make it more like I think of it like chess. You're playing this board, and every move has consequences all over the board. And the more chess moves you can think through, the better player you will be.
Yeah.
And I feel like these other design books are giving very basic rules, like don't sacrifice a piece unless you want to, or things like that. Like don't block your pawns, things like that.
When you do the
exactly. And the rules are true until you get better, and then it's not useful anymore. And I want to do something more like, here, when you're thinking about a move, here's 5 things to think about, and so you can start to see that. And I'm not telling you what the right move is.
No, exactly.
I'm just telling you, like, these are useful things to keep in mind.
Yeah.
And because I have this conjecture, a hypothesis, that the more design decisions the more options you see at each decision point, the better designer you will be.
Yeah, I really like. I don't recall exactly how you said it in the presentation, but you got it in there very clearly and very nicely. And it's like, yes, of course.
Yeah, right. And
like,
it seems to make
consider
sense.
a few more options.
Right. And so another thing is these lenses will open up your mind to new decision points that you didn't even realize were there, right? So I've been having discussions with people. We're here at a conference. It's hallway track is like one of my favorite things.
Yeah.
And people will be like, well, should I do this or this or this? I'm like, yes, that's the right question. I can't tell you the answer. Like, your code base is yours. Like, it depends on it's all interconnected. But that's the right question.
Yeah, exactly. And I feel like it's on to so many good things as well, because I started thinking of one colleague in particular who's really good at reasoning about the model, and I felt like I'm getting a lot of useful words and concepts here for describing or thinking about the stuff he does.
Ah, cool.
Because he's really good at reasoning out a good model for something. And then you end up getting those interesting interactions with the, what did you call the levels? The model level and the domain and the model.
Oh, right.
Oh, yeah, and how those interact with each other.
Yeah.
Because he can be really good at reasoning out a useful model, and you talked about that as well. You have concepts that are not representable on one side, and concepts that exist, and sometimes you realize you can implement.
Right. Well, that's one of the things I've been trying to do is bring a little bit more objectivity to design.
Yeah.
Like, it's still intuitive. There's still too much for your brain to really process. You have to use your intuition. But there's a lot that can be maybe more quantified, and like you can tell people, like, no, this is a problem and this is why. So the thing you were talking about is, like, let's say you have a data model for a domain, let's say coffee shop, because it's easy to talk about.
Yeah.
So your model has certain states that are representable. And your domain, at least the way you've analyzed it, the way you've conceptualized it, has also a certain number of states that it can be in. And you want to compare the two. Like, what is the overlap?
Yeah.
And there's actually, if you look at a Venn diagram, there's going to be three areas. There's the overlap. There's going to be the area that's in the domain that's not representable in your model. Yeah. And then there's the part in your model that doesn't have anything corresponding to it in the domain. Yeah. And if you have a complete overlap, then you have perfect fit.
Yeah.
But if you don't, then there's some problem, and you want to minimize that, and you also want to make sure that you can represent every state you want to.
Yeah, exactly.
And so it's better to have maybe more states, but then that causes you to have some kind of check to make sure you don't get into one of those states.
Yeah, it's always sort of friction there.
Right. But these are all just trade-offs that you're like trying to balance all the time, because you're never going to get a perfect model.
No, and you probably shouldn't either.
Right.
Because some of those simplifications or unrepresentable things will be what makes the solution more useful to the users.
That's right.
Like, we have so many things. We make a scheduling system for universities at work.
Okay.
So, there's a lot of flexibility that you don't want to expose to people unless they really have to.
Right.
Permissions.
Right. You want to restrict it.
Yeah, exactly. And you can make it seem really simple in the front end to the users, or as simple as possible at least, but still represent everything that's needed.
I see. Yeah. No, that makes sense. No, that's really cool.
Yeah. And sometimes you simplify too much, and then it's like, someone needs this aspect.
It's a hard job, all this design work.
But you had that in there as well, with the open, closed, the different levels of how hard the thing is to change. That's a really useful thing to think about as well.
Well, that's another pet peeve of mine is, again, I don't want to step on anybody's, I don't want to kick dirt on anybody, but I feel like in the move to agile, because they talk about changing requirements and also learning as you're programming. Like you put out a feature and you learn, it's not what the users wanted. Like, that's all good, right? But with that, they have made this popularized this idea that change is maximal and unpredictable. Like, anything might need to change. So in software design, just put indirection everywhere. Always have an interface in between, classes interacting, and it's not true.
No.
A lot of change is predictable. And it's not maximal.
No.
It's not going to change. Not everything can change. And some things is, code is also changeable.
Yeah, of course.
You can just change the code. That's why we have editors.
Yeah, we do it all the time.
It doesn't, I also think there's this other thing that happens, which is I don't think there's one cognitive bias that describes it, but it's a thing that happens in casinos where people are gambling, And they remember their wins much more than they remember their
yeah,
losses.
Yeah, of course.
So they could play 100 games and win 3 and feel great, even though they've lost 97% of the time.
Because one of the last ones was a win. So
yeah, exactly. Yeah. Or they end on a win or whatever. So I think that we put in indirection because we're anticipating changes in our code. And let's say we put in 100 and 3 of them hit because some new requirement changes. And we're like, yes, you see, it was all worth it. And it wasn't.
No.
It was not worth it for 97% of those. And you spent time on them and you used valuable resources and made the code more complicated.
Yeah, exactly. You could have had a simpler thing.
That's right.
Yeah.
And it would have been easier to change anyway with the simpler
thing.
Of
course. It's just an if statement.
Right.
And 3 cases.
That's right. That's right. So we're putting all this, some people say like you spend 10 lines of code today to save 10 lines of code tomorrow. But that might never happen.
No,
And so why are you doing the 10 lines of code?
No, exactly.
Yeah.
I could have written 3 instead. And I think it goes together so well with, for example, the last keynote yesterday, Natasha, when she talked about, your code often outlives you in a context.
Right.
And that rings very true to me.
Yeah.
We don't really want to admit it, but so many things we write and we think, it has to be fast. We have to do it quickly. But then it goes on runs for 10 years somewhere.
Right. That's right.
And we have to read it as well. And
it's so scary.
Yeah, both scary and not, I think. I mean, it's kind of...
Yeah.
I think it's a nice counterbalance to realize that when you're sprint planning and everything seems like it has to be done so fast.
Right, so urgent.
It's still, exactly. It's still worth thinking for 20 more minutes about options.
Yeah, sure. Yeah, and we're so weird about time.
Yeah.
I watched a talk once where they were talking about writing a better commit message. And it was basically like, sit down, you're done, write it all out. Yeah. Just take some time, write it out. And people are like, but it's going to take so long. Yeah. And he's like, I'm just talking about 5 minutes.
Yeah.
You spent like 3 days on this code.
Yeah.
Take 5 minutes. Yeah. Write it down.
Yeah.
Before it's out of your head.
Yeah, exactly. Do it right away. Do it somewhere.
Yeah. But I also feel like that those 5 minutes, it does only take 5 more minutes, but we're also so distracted at work.
Yeah.
Like we've got Slack messages coming. Like it does pop out of your head. And now it's more than 5 minutes because you have to remember where was I, and it's not so easy anymore.
Yeah. And we keep telling ourselves that for some reason, if we write the code well enough, that we never have to write anything again.
And that might be true if you took more time on the code.
Yeah, it could be. It could be. Hopefully, but
But again, we're just talking about spending more time on it.
Yeah, but not that much.
Yeah, no, it's true. Yeah.
Maybe we should think about time spent instead of lines spent, like you said.
Yeah.
Spend some more time now to save some time.
I mean, I also know in my experience, I am often so looking forward to the end of this whatever ticket I'm working on. Like it's finally working. Like I just want to get it out of my hands. Like I totally understand it, especially since there's a sprint end coming, and I want to get it in before then. And I have a meeting coming up in that afternoon, and I hahaven't eaten lunch yet.
Yeah, and nobody really cares how it's done.
That's right. That's right. I'm not going to get extra points for doing a better job.
No.
So I totally understand it.
Yeah, it's a tricky tricky situation. So what got you into the path of like thinking about domain modeling, for example, in the first place? Did you start out like working program and then started wondering how to make it better, or?
Here's a story. I read back when I was in college, I guess. I was reading a lot of stuff about programming, mostly from like Unix hacker culture. And one person said that he felt like he liked programming. He was drawn to programming because he liked the control.
Okay.
Like he liked that you had this hardware that you could totally do what you wanted with. And I kind of got it, but also like, well, that's not me.
Yeah.
I like that code lets me play with ideas. I'm not a hardware guy. I'm not I want to configure my machine just the right way. I'm more like, I want to be, I'm happy working on a whiteboard, but code, what I like about code is it's more formal. So you have to get it right. You can't just draw a picture with some arrows and be like, and then this happens, then a miracle occurs, that old joke. I like the fact that code forces you to make it work.
Yeah.
And when you realize it doesn't work, it's like you have to now debug your ideas.
Yeah.
And then try something else.
Yeah.
And I just, that's what I like about it. So it's always been about expressing ideas, which is what domain modeling is.
Yeah.
It's like, what are the ideas here that are important? How can we encode them in our code?
Yeah, that's extremely close by now that you put it like that.
Yeah. And I've also found that the jobs that I've liked the most, the companies I've liked working for the most, at those jobs, I became kind of well-versed in the domain.
Yeah.
I wasn't just a coder, doing what they said. I was learning really deep stuff about what I was working on. Sometimes more than the boss, it's like I had a better understanding because I had to actually make something work.
Yeah.
I had to make trade-offs. I had to simplify it. I had to figure out what are the edge cases and things like that. And often, the boss had a, more salesy approach to it. This is how we can sell it to a client, and that's very useful and everything. But in terms of the technical details of how accounting works or something, I knew the corner cases and the.
This is what actually goes on here.
Yeah, exactly. And that was, I actually use it as a way of judging a company. So when I'm interviewing at a company, I'll ask the programmers there, do you feel like your day is spent mostly figuring out why the message queue is dropping your messages and how to, deploy your microservice? Or are you thinking about, e-commerce? And are you working in that realm of ideas? So it's a way for me to judge how are they in this over complex ops situation where they just become I don't know, server babysitters.
Yeah, exactly.
Or are you actually delving into the realm of ideas and really reaching in and playing with that? Because that's where I want to be.
Yeah. It rings a bell but in relation to that, I often feel like people talk much about languages and platforms, but what's really interesting is actually the stuff you're talking about, the model, the domain, learning what this company does with that code.
That's right.
And I like to say that I don't feel I know C++. I would never call myself a C++ programmer, but the C++ code we have for our domain and business logic, that I can do because I know something about our domain. I know how our thinking goes.
Right.
And that makes me able to write C++ in that case.
Yeah.
As long as someone else double checks the memory.
Well, no, but that's great.
Yeah.
Memory management in C++. I understand.
But it's really about...
No, that's cool. That's awesome.
Yeah, and models are powerful.
Yeah. And I want to help more people and companies get there.
Yeah.
I feel like places I've worked at recently, they're just so mired in the complexity. And I talk to the people, people who kind of architected the system, and they love it. They're more of those control people. They're like, oh, isn't it cool that we can orchestrate this and the deploy happens like this? And I'm like, meh. I mean, it's fun for you, but it's not what I want to be doing.
Exactly. And I keep thinking that when it comes to the actual important model and these parts, they shouldn't be that much code.
Right.
So when people are talking about these towers of architecture, I feel like they're often lost in the woods somewhere.
Yes.
On some level. I mean, on another level, of course, they're talking about important stuff. But
well, it's like forest for trees,
yes,
right?
Something like that.
they're seeing the background, and I'm like, but this is the important thing is the e-commerce thing you're building, not how the queues work.
Yeah, exactly. Can someone actually buy something? It doesn't matter if there's that's a fax generated in the background.
Does people had to invent the idea of the online shopping cart.
Yeah.
And does your shopping cart domain model correspond to the operations that the person has, or is there some like big kludge going on that behind the scenes is something totally different? Like, I think it should be much more similar. They should map to each other. The buttons that you click in your shopping cart should have like a method on that object in the database.
Exactly.
So I think I think there should be a much closer mapping.
I guess the better the fit there, the more obvious everything seems.
That's
I think.
Right.
Like,
That's
the object just happens to have a property for everything I want to do.
Exactly.
Isn't that strange?
Yes. That's right.
Yeah, no, I also want to throw in that it feels like if you know the model really well, you can often write simpler code as well.
Yeah.
Because, this is the concept we're dealing with, but we don't need a class for that. It can be an if statement for now.
Right.
Because that's what it represented at this
Exactly. And then the other challenge is we often are learning as we go.
Yeah.
So we can't really know the model that well up front. You can know something, and then you have to evolve it over time. And so that often means refactoring, right? Like, this can't just be an if statement because we have 25 different things. That's just not good code. And we're at 24. Like, maybe it's time now before we add the 25th one to find a different system.
Could be.
And so I'm really fascinated by this idea of refactoring as a way of finding the seams in your model. Right? That is there some way, because when you look at software design and static analysis, like people do like complexity measures and things. My trouble with it, I mean, it's all useful, but my trouble with it is it's all just looking at the code.
Yeah.
It's not comparing your code to the domain.
Yeah.
To the, what is it supposed to look like? It's because maybe your domain is really complicated.
Yeah.
Maybe a 24 branch if statement is correct.
Yeah, it's the simplest thing it could be.
That's right. Yeah. And so I've always had trouble with that. But at the same time, I've seen people who are very skilled who don't know the domain that well. They look at just the code and they start to organize it, refactor it, redo it, and they come up with an interesting domain model without really having ever seen the domain.
Yeah.
And so they've intuited a way somehow to do that. And so I do think that what they're doing is domain modeling. And this is another, again, I'm going to kick dirt. But the problem is they talk about the refactoring. They're like, see how important refactoring is. But it's like, okay, refactoring is just your way of modifying code.
Yeah.
So that the tests don't break while you're doing it. That's important. But what you're really doing is finding domain. You're finding domain concepts and modeling it into things in your language classes or types or whatever you do. And so I'm following a thread right now. I'm watching all these refactoring talks, and I'm pointing out like, hey, look, they're talking about refactoring, but the important thing is they found a domain concept that we hadn't realized was there, you know? And so I guess I would like to steer the conversation away from refactoring is the answer. It's like, no, it's part of the answer. The other answer is like finding these interesting domain ideas.
Yeah, it's like coding
and organizing it better. Yeah.
Coding isn't like finger tapping on keyboard.
That's right. That's right.
That's an important part of it. In a
that's
way,
right.
But
Yeah.
It's not the whole story. So you're working mainly in Clojure?
Yes.
Yeah,
I think it's time. I've been doing Clojure for so long now. It's time to reach out into other languages. Like so much is new. I have played with TypeScript, and I really like it. I think it's a good maybe the best possible design for a superset of JavaScript with a static type system. I want to look at Rust now. I have enough friends who are like, yes, Rust. I'm like, I was not sold on it, but I'm kind of a curmudgeon, I'm kind of like, new technology, like stuff. Like,
does it have a repo?
I don't need to spend all my time on new stuff just to have it disappear. But Rust looks like it's here to stay now, so it's worth.
Nice tutorial.
Yeah, and enough people are talking about it. It's worth looking at.
Yeah, I talked to one of my colleagues in the pod, and he was like, I haven't heard a lot about Clojure in a while. Is there stuff going on there? It
is, yes. It's one of the more popular languages. I mean, maybe top 25 or something.
It's better than many.
Yes, exactly.
Larger than many.
And we're trucking along just fine. Yeah. The language hasn't had one of those like cool new feature things in a while. No. But it still works really well.
Yeah, I mean, you don't need to add new stuff all the time.
I know. That's one of the things that I've been hesitant with Rust about. It's like a very big language in terms of the number of features it has.
Yeah. But have they sort of stabilized now, or are they still adding? No,
I don't know.
I don't either.
Yeah. Yeah. No, I remember back in the day when people were like, I wrote some Rust and then I upgraded and now it doesn't work anymore. I didn't want to be dealing with that. Now it's not like that anymore.
No, the same person he described it because he was maintaining Rust packages for a Linux distribution or something, and he described it sort of like chasing a wave. You have to stay in sync with it, or you're toast. But he was also clear pointing out that they shouldn't optimize for my use case because I'm a maintainer of these packages. They shouldn't be doing that. They're doing the right thing right now.
Yeah.
It was a couple of years ago as well, so I'm not up to date.
Yeah, I'm a fan of Clojure. One of the reasons is it's a small language. It's relatively simple. Yeah. Like you can learn all of it, and then you're done. And even then, I choose a subset of it, you know, that I work in. Whereas, again, something like Rust or Haskell, I worked in Haskell. Like it has this syntax cheat sheet that's like 4 pages long. I'm like, what does this thing mean? This little symbol. I got to go look it up. Yeah. And that, it's fine, but it's not my favorite. No. Yeah. I like to have it small.
Yeah, I find that very appealing as well. Yeah. I mostly write JavaScript. Looking sideways at TypeScript. I should be doing more types, that's for sure.
I find the types in TypeScript are quite comfortable for modeling.
Yeah. I mean, they fit in really well in the examples when you use them.
Yeah.
But then the slides became too small. Exactly. And I feel like that's also sort of indicative of a thing with TypeScript.
Yeah.
Sometimes things can get a bit...
One of the things in Haskell that I like is the type goes above the function. Instead of having the types be like next to the argument, they're above it. Yeah. So the type is really like its own thing. It's clear, it's there, and then you don't have to write the types again. Yeah. Whereas in TypeScript, you have to do a colon and put the type name next to it. So then your function gets the first line of the function gets really long.
Yeah, exactly. Yeah. So looking at other languages. It's mostly about curiosity about the differences, or
and it's time to grow. Yeah, personally, I said I teach Clojure, and I did that full time, selling video courses for 5 years.
Wow.
Yeah, and then I was having trouble paying the bills, making ends meet, and so I had to get a job. And I really think that the community just wasn't big enough to support someone making full-time living teaching like that. And so part of me is like, I could teach Rust. Like, there's a lot of people who want to learn Rust.
And there are a lot of TypeScript people.
Yeah,
as well.
a lot of TypeScript people. And so if I get better at it and find something to say about it, I want to be unique. I don't want to just give the same lessons that other people would give. But bring my own unique take to it, then I might teach it. Yeah. So.
I mean, it goes along really well with the domain modeling. So
yeah, it's true.
It's Yeah.
That's true. And so, like, I'm writing this book on domain modeling. I think I'm going to use JavaScript again, because that's what I did my last book in, and it was, good reception. But I think it would be cool to have like a Rust edition a TypeScript edition, or, things like that. And I need to know the language well enough to not embarrass myself.
That seems like a reasonable way of doing it. I just translate it. I ask the model to do it for me.
Yes,
what could possibly go wrong? Yeah, this was super interesting. Thank you so much for taking the time.
Thanks for the time. This was great.
Tusen tack för att du lyssnar på Kodsnack. Vill du stödja oss? Tipsa en bekant om podden eller lämna en recension i till exempel iTunes. Du kan också köpa prylar med Kodsnacktryck eller stödja oss med en kaffe på coffee.com. Alla länkar och alla avsnitt finns på kodsnack.se.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.